The law of large numbers says that in the long run, a random variable settles into its true probability. And a nice example of this involves coin flips. If we were to flip a coin many times, it will settle into its true probability of 0.5 for the proportion of heads. And you can see that graphically. Along the x-axis here are the number of coin flips, and along the y-axis are the proportion of heads, and sort of a running proportion as the number of coin flips grows. Here's a list of the first 20 outcomes of the coin flip, and you can see that initially we got tails, and that accounts for this starting location, that after one coin flip, we have 0% heads. And then we received heads, and that took us back up to 0.5, because now half of our results are heads. And then we got two tails in a row, which put us down to 0.25, a quarter of our results are heads at that moment. And then we got four heads in a row, so that sent us all the way up here. So at the end of 8 coin flips, we now have 5 heads, which is 0.625, or 62.5%. And then we continue on and on, getting a variety of heads and then tails. And you can see that if we keep plotting the proportion that are heads, we start to settle into this yellow line at 0.5. And that's what the law of large numbers says, that as the number of coin flips grows, even though you get large fluctuations early on with a small number of coin flips, that in the long run, your proportion of heads will settle at 0.5, or the true probability. It's important to note here that the coin is not in any way compensating for earlier coin flips. What's happening instead is that the sheer volume of coin flips down here and into the future is overwhelming any streakiness that occurs earlier on. So just because we see a bunch of heads in a row early on doesn't mean we're going to see more tails like that later on to compensate. Rather, the sheer volume of coin flips still to come will overwhelm any streakiness that occurs early on. And that's it.